Welcome to Chapter 22, where we talk about the respiratory system. Your chapter recommends that you go back and review mucous versus serous membranes. So mucous membranes would be usually in the openings, like in your nose, and the serous membranes are the folded over membranes that surround your heart and your lungs. So both of them provide fluid, both of them lubricate, but mucus is more in open areas and is more for catching things, and the serous membranes are more for preventing friction. This chapter, the one before it and the one after it, all are going to require you to remember things about hemoglobin. So if you've forgotten hemoglobin, you might want to go back and look at that. Also, hopefully everyone knows that diffusion goes from a high concentration to a low concentration. If you stop and think, that makes perfect sense. If you put on perfume, it doesn't come back onto your body. It goes away from your body. It goes from a high concentration where you just squirted it on to a low concentration further out in the room where it's diffusing outward. It's amazing when we study these chapters to realize how much the lungs depend on the heart, and the heart depends on the lungs, and the heart depends on the urinary system to get rid of excess fluid, to get rid of waste. So this chapter deals with respiration. If you inhale, we say you are inspiring, and if you exhale, we say you are expiring, which is kind of interesting because that's also the word for dying. Seems like they could have come up with a new word instead of using the one that's already there, meaning dying. Respiration that we're going to be talking about in this chapter has to do with what the lungs are doing, but we learned in another chapter about cellular respiration, and that's down in the cellular level, and that's where you take in the oxygen and you create ATP energy. So this slide is a little bit confusing because they're talking about ATP and they're talking about cellular respiration, but we're going to be talking about taking in oxygen and getting rid of carbon dioxide, which is just considered to be respiration. All of us know that we use our lungs for breathing, bringing in oxygen, breathing out carbon dioxide, but you also use it when you're crying, when you're talking, you push air out. When you're going to sing a high note, you take a deep breath and then let it out so that you can sustain the note for a long time. You need your olfactory system to work with your nose and being able to smell. Olfaction is the fancy word for smelling. You also maintain an acid-base balance in your body because carbon dioxide dissolves in fluid and becomes carbonic acid. So if you need your blood to be a little more acidic, you're going to hang on to some carbon dioxide. If it's too acidic, then you can just breathe out some carbon dioxide and the pH will go back up. So a lot of people don't even realize that we do that. Another thing you do with your lungs, oddly enough, is regulate your blood pressure. Your lungs, we're finding out, we've always known it, but only just people who take classes like this know about it. But now with the advent of COVID, pretty much everybody knows that your lungs have ACE2 receptors. And it just so happens that COVID really likes ACE2 receptors, and ACE2 receptors allow the coronavirus, into our lung cells. And then, of course, they take over and make new coronaviruses, and then we spread COVID through our lungs. So if we could keep COVID out of our lungs, if we could keep the coronavirus that causes COVID out of our lungs, then we wouldn't catch it. You can't put it on your hand and catch it through your fingers, or get it on your arm and get it through your skin. It doesn't work that way. You've got to put it in your nose, either by breathing where somebody's coughing that is already sick, or put your hand in some place where the coronavirus is, and then reach up and touch your nose and inoculate your nose. So again, one of the good reasons for wearing a mask is so you don't touch your nose or your mouth to give yourself the coronavirus. When we talk about the formed elements of the blood, we talk about white blood cells, red blood cells, and then the megakaryocytes that break down and make platelets. And most people are surprised to find that about half of your platelets are made by the megakaryocytes in your lungs, and the other half is in your bone marrow. Most people would think that it was all in the bone marrow. There is a pressure gradient between the thorax and the abdominal diaphragm, and that helps lymph move up, get to the heart, and rejoin the circulatory system. So just the simple act of breathing in and out pushes lymph up into the heart so that it can be recycled. Your lungs also filter tiny blood clots, not big ones, but little blood clots that are in the bloodstream and dissolves them. So you catch the blood clots when they're really tiny, dissolve them, and then they don't continue to grow and get larger and larger, and then cause damage by clogging up an artery or a blood vessel. And last but not least, we also use our abdominal muscles, the diaphragm, to push down and cause you to have a bowel movement or to urinate or have a child if you happen to be a pregnant female. So one of the things that my students told me about that I thought was rather interesting, since so many of them are EMTs, or they're moving on up, they want more responsibility, more money, another job. Anyway, for whatever reason, they always, when I come to this part, the ones in the audience will go, oh, because when you're called in as an EMT, a lot of times you find a dead body. And a lot of times that dead body is on the toilet. So when you push with your diaphragm, you're also pushing up against your heart. And sometimes it stops your heart. So they name this Valsalva. So I am not making this up. Here's Valsalva. Now we need to talk about all of the organs that make up the respiratory system. Luckily, with the exception of the pharynx and larynx, you're probably familiar with all of the words. So the air enters the nose or the mouth and goes into the back of the throat. So the pharynx is the back of your throat, the back of your mouth, where it joins with your throat. And you come down, and the voice box is the larynx. And for guys, it sticks out, so they call it Adam's apple. And then you go down the trachea, and the trachea branches out into the bronchial tubes, and you've got one that goes to the left lung, one that goes to the right lung. And then as you go further, the bronchial tubes break off into smaller bronchial tubes, which break off into smaller bronchial tubes, until you finally get into what we call bronchioles, which just are little bronchial tubes. And then you get to the part that actually does the gas exchange, and those are called the alveoli. And they're just flat little squamous epithelial cells. Sometimes you hear someone say, well, I have an upper respiratory infection. Or someone else says, oh, I have a lower respiratory infection. Well, depending on who's writing the book, the upper is your nose, your throat, all the way down to your voice box, and some include the trachea. Others say, no, the trachea belongs in the lower respiratory system, so it's trachea and bronchial tubes and the alveoli and the lungs. So somewhere in this region, up is upper respiratory, and somewhere in this region, down is the lower respiratory. But basically, if you're coughing up from your lungs, it's lower respiratory. If your head is all congested and your nose is congested and you got snot running out and your eyes are all puffy and watery and red, that's upper. So it's kind of not worth fighting over. The guy who writes your books puts the trachea in the lower respiratory tract, just so you know. Some of the things you do with your nose is to warm and moisturize the air or humidify the air that enters your body so you don't dry out your trachea and you don't dry out your lungs. You also detect odors with your nose, and you have little nose hairs and mucus which should catch particulate stuff, hopefully pathogens, worm eggs, spores, things like that are going through the air. And then you use your nose to resonate and amplify your voice. So one of my favorite singers was Barbra Streisand. She's still around, but she had all this money because she was such a fabulous singer, and she went to the doctor to say, well, can I get my nose fixed? It's rather large. And the doctor said, well, you can easily fix your nose, but you won't have that voice that you have, because a lot of your voice resonates in your nose. So she keeps her nose and she keeps singing. From time to time, I tell really bad jokes, and one of them that anatomy teachers seem to enjoy is, how do you break a little kid's finger? Well, you hit them in the nose. Stop and think about it. Where are little kids' fingers all the time? They're always picking their nose. I don't know whether it's because there's salty things inside of there or because they're told they're not supposed to, but it's universal. So the nostrils are usually called the nares, N-A-R-E-S. And here's your pharynx, the back of your throat, your larynx, your voice box. Your trachea has these rings, so you have thick and thin cartilage, and that's to allow you to be flexible so you can bend your head and look down, but you want it rigid enough that it won't collapse when you're breathing. Especially when you lay down, you don't want your trachea to collapse. You can always tell the right lung from the left lung, one, because there's 3 lobes on the right side, but the left side only has 2 lobes, and it has a punched out cardiac notch right there where the heart pushes into it. If you look at the trachea, here you see it branching off, goes behind the aortic arch of the heart. Here it is coming down, and then it branches off, and then it branches off and branches off and branches off. So they're just showing you some of the branches, but it continues to branch and goes all the way out to the ends of the lungs. So pointing out some of the interesting things in this particular slide, if you go up in the nose, up through the nostril, you're going to get into an area where you have 3 folds called concha, and this area between the folds is the meatus. So there are 3 meatuses because of the folds in there, and it's to slow down the air and it's to moisturize it. But an interesting fact is these concha swell up on one side of your head every 30 to 60 minutes, and then they release and the other side swells up. And you do this to allow one side to re-moisturize, relax, get rid of some of the stuff that it's pulled out of the air. So notice when you're sleeping, especially, it seems like that's when I notice it, you wake up and you can only breathe out of one side of your nose, and the other side is completely blocked. But if you roll over, then that side will open up and the other side will close off. So this is to keep you from drying out your nose, because it's really important to keep your respiratory tract really nicely moisturized. So you want to slow it down and moisturize it as it goes through. Another interesting fact is in between the left and the right nostril, you can put your finger in your left side or your right side. Don't pick your boogers, but you'll feel a septum dividing the two sides. If you sniff cocaine, it will eat through that septum, and so you can put your finger in one side and stick it out the other side. Another thing that will eat away the septum is if you overuse nose spray. So if you look at the over-the-counter nose sprays, they always say, do not use this more than 3 days. If you have to use it more than 3 days, then you need to go see a doctor because there's something wrong. So I know people who are addicted to nose spray. I mean, they just use it all the time, and they're missing their septum. So that's kind of an interesting thing. Now, if you're the kind who is curious about yourself, you can take your little finger and get it wet and put your finger up your nose, and you can actually feel the concha and the meatus. You can slide your finger into the folds. It feels really weird. It's like, because when I saw the picture with the first time a long time ago, I thought, I wonder. And so my little finger being the smallest, I just got it wet, stuck it up in there, and started feeling around. So, enjoy. When you were learning the bones of the skull, you learned about the ethmoid and the sphenoid bones, I hope, and they make the roof of your nasal cavity, and then the hard palate forms the floor of your palate. And it allows you to breathe while you chew by separating the two areas of your nasal and your oral cavities. One of the most common birth defects that you're going to see are people whose hard palate, here's the hard palate right here, it doesn't completely shut. So as you're a fetus in your mother, and that's coming together, sometimes it just stops for some reason, and then you end up with a hole or a cleft in your palate. And so they have to go in and they have to fill it in so that you're able to swallow and talk correctly. One of the things I challenge my students to do is, how many ways can you get into the trachea? Well, you could come up from the stomach, not from the stomach. You can come up from the lungs, not from the stomach, through the trachea. You can come up through the esophagus. So sometimes you vomit. It comes up out of your stomach, up through the esophagus, which is behind the trachea, and out through the pharynx. So you can get there from the trachea, from the esophagus. You can get there from the ear. So you have a eustachian tube in your ear, which is kind of interesting, and it allows fluid, unfortunately, up into the ear. So that's one of the reasons they say don't sniff. Don't sniff, because if you sniff, you'll actually suck bacteria, fluids, viruses up in behind your eardrum, up through the eustachian tube. So that's another way that you can get into the mouth, the throat. And another way, of course, is in through the mouth. Another way is in through the nose. Another way is in through your eyes, because when you cry, think about it. Some of the tears roll down your cheek, but some of them run into your nose and run down into your mouth. So you have a connection that way too. And some people who are very creative can actually put milk in their mouth and squirt it out through the ducts in their eyes, so they can squirt milk out of their eyes. Again, when you guys were learning about the skull, I hoped you learned about the sinuses. So you have paranasal sinuses, and they can drain down into your throat too. So sometimes you can actually see it. You can open your mouth, and your doctor will put a little tongue depressor down to push your tongue down, and they can actually see strings of mucus hanging down in the back of your throat, down in your esophagus. So there's yet another way that you can get into the pharynx, or the back of the throat. I obviously find anatomy physiology fascinating, or I wouldn't be in this field, but I also like really weird stuff. So when you stop and think about the olfactory mucosa, if you breathe something in, it has to dissolve in the olfactory mucosa, and that will trigger the receptors on the cilia that are inside of your nose. So let's think about some of the things you smell. So you go in the bathroom and you go, oh, the person behind or in front of me already went number 2 in the bathroom. The only way you know that is some of their fecal material is in the air and it dissolves in your mucosa and you detect it. So that's one of the grosser things. But one of the nicer things, if you're sitting there with someone you love and you're smelling them and you notice, oh, they've washed their hair with strawberry soap or shampoo, and oh, they're wearing my favorite cologne, and oh, they've been working out a little bit, so they got a little bit of a smell under their arm. All of those things, you're taking in part of that person. You're actually dissolving a part of that person's molecules into your olfactory mucosa, and then you're detecting it with the receptors in the cilia. So you can look at it grossly, or you can look at it interestingly or lovingly. Another fun thing to know about the things that dissolve in your olfactory mucosa, when women share one whole floor in a dormitory and they share bathrooms, one of the women will be an alpha and she will make pheromones, which is kind of a olfactory hormone. Instead of going through your bloodstream, it actually goes through the air. And it's picked up by the girls that go into the bathroom after her. And when she starts her period, she's going to release something into the air. And after a very short period of time, all the women on that floor will all have their periods at the same time. So they've done studies on this, and I just find that fascinating. Another fun thing to know and tell about the nose is it's made up partly of connective tissue, partly of cartilage, the septum that I talked about that can be dissolved away if you do enough cocaine or enough nose spray, is cartilage. And then you have the bone up here, the nasal bone. Now, there is, depending on who you look at on Wikipedia or on the internet, if you strike somebody in the nose and hit them with an upward thrust, you can take this nasal bone and kill the person. I personally don't believe that. I don't want to try it out. But if you stop and look what part of the brain it would be penetrating, it would be the frontal lobe. And in the past, they used to remove the frontal lobe in people to control their behaviors, to control their emotions, to control their actions. So frontal lobotomies were, watch One Flew Over the Cuckoo's Nest if you want to know more about frontal lobotomies. The other thing that is kind of aggravating, especially for people my age, is we stopped growing when we were 16, 17, 18, depending on if you're a boy or if you're a girl. And then we started shrinking. But for some reason, when you get old, the tissue in your ear and the tissue in your nose starts growing. So don't stare at an old person, but if you can just kind of look at an old person without them seeing you, check out their ears and check out their nose. Interesting. Why would you do that when you get old? Same thing with your nose hairs. You have really stiff hairs that block insects from flying in your nose and dust and things like that. But again, look at older people. Their nose hairs have started growing, and so they have to clip them. Isn't that odd? One thing I've noticed about the guy who wrote this book is he renames everything. So now he's trying to call the concha turbinates. So if you see concha, it's those folds in the nose. If you see turbinates, it's the folds in the nose. Same thing. Here's how you spell meatus. It looks like meat us. It's not meatus. Or meatus is. You have several of them in both of your noses. When we look at the kind of tissue that makes up the respiratory system, it's interesting. You should hopefully have done a histology section in first semester where you learn the different kinds of cells and their functions. If you haven't, I have a YouTube video you can watch, Karen White Drake 1, and you can watch. You can see all the different tissue types. So coming into the nose, you have ciliated pseudostratified columnar epithelial cells. The important part for our purposes that we're talking about right now is the ciliated part. So it's little hair-like projections that stick up off of those cells and they wave. And then beside them are goblet cells, and the goblet cells make mucus. So you've got these little waving hairs, and you've got these cells right next to them squirting mucus out, which you and I would call snot. And it moves the mucus along. So it literally is washing your nasal cavity out. Now, these cilia are going to be pushing the mucus backwards, past the nose, back down, and then ultimately into the pharynx, where you can swallow it into your digestive tract. In a minute, we're going to be talking about the trachea. It also has ciliated cells, and it's going to be pushing the mucus upward towards the larynx so that it can get up to the point where the trachea and the esophagus join. And it'll come up the trachea and then down the esophagus and into the stomach. So you've got mucus being propelled by cilia down from the nose and up from the trachea. Those cilia that I was talking about that pick up the smells, the olfactory mucus, they're immobile. They don't wave, but they're only in a small area of your nasal fossa. So most of it is moving the mucus along. Only a small area detects molecules that are in the air. You should take a second right now while you're listening to me and cover up one nostril and breathe out of it, and cover up the other nostril and breathe out of it, and see if you're breathing more out of one than the other. So it should shift between the right and left side once or twice an hour. Here's another cutaway picture so we can look at various things. Here's your frontal sinuses. So if you get an infection in the sinus, you're going to have a headache between your eyes and kind of under your eyes. And here are your concha, also known as turbinates in this book. And they've renamed the eustachian tube the auditory tube. So the auditory tube is the one that goes up and then behind your eardrum. So you have a connection. So if you get an infection behind your eardrum, it should drain down the auditory tube and you get rid of it. But if the auditory tube gets swollen, then any bacteria or fluid gets trapped and it can't drain out. So it builds up behind the eardrum and can actually pop the eardrum. So sometimes if you've ever had an earache and then all of a sudden you just have this fluid rushing out from your ear and down your cheek, that you've ruptured your eardrum. So that's going to leave a scar tissue when it heals back. So if you have an ear infection, you probably want to take an antibiotic to take care of that, kill the bacteria before it ruptures. Now, little kids are short, and their eustachian tube or auditory tube is almost horizontal. So it's just as easy for the fluid and anything that's in that tube to go up behind the eardrum as it is to go down into the throat. And little kids don't know that for some reason they don't want their nose blown. So you go over with a Kleenex, you want to blow their nose, and instead they start sniffing really hard. And then they end up with an ear infection. As you grow taller, the angle of the auditory tube or the eustachian tube becomes slanted. So now it is harder for the fluid to go up the eustachian tube and in behind the eardrum. So as you get older, you get fewer and fewer ear infections. Let's see, what else do we need to talk about? The soft palate is behind the hard palate. And the uvula. The uvula is kind of a cool little thing that hangs down, and it swings over so that when you swallow food, you want it to go down in the esophagus. You don't want it to go up into the nose and come out your nose. If you bend over while you're swallowing, it causes the uvula there to swing forward, not to be confused with the tonsil, which is on the other side over there. But the uvula is that little thing that hangs down in the back of your throat. It'll swing forward, and when you think you're swallowing, because your head's bent over, it will go out and come out your nose. I first discovered that when I was swallowing a Tootsie Roll and bending over to pick something up off the floor at the same time. And the Tootsie Roll came out my nose. Here's a picture of someone sneezing. And this is one of the things when they talk about wearing a mask and it's going to protect you from somebody sneezing who has coronavirus or COVID. These larger particles might get caught, but there's enough viruses and particles in there that it'll easily go right through most masks. So again, not saying don't wear a mask, but the mask will probably do you more good that you don't touch something than it blocking these particles. So here's the epiglottis, the glottis, the vocal cords, and you can see the rings of the trachea in this person. So this person is in the process of coughing. This is a cross section through a trachea, and you can see the pseudostratified columnar epithelial cells right here, and you can see the cilia lining it, the little hair-like projections, or at least I hope you can see them. Now, once you get out of the trachea and you go down into the bronchial tubes, you don't have as many cilia, but you still have cilia going down into the bronchial tubes. This is kind of a neat picture. What they've done is they've filled the trachea and then the bronchial tubes up with something that hardens them, and then they've eaten away the rest of the lungs. So this just shows you the bronchial tubes and the bronchioles as they branch out. And you can see the shape of the lungs there. For those of you who've forgotten where your sinuses are, there's your frontal sinuses, your ethmoid sinuses, sphenoid sinuses, and maxillary sinuses. So you can get any of those infected, and then you say, oh, I have a sinus infection, or I have a sinus headache. Here's an autopsy picture showing the trachea. You can clearly see the thick and the thin bands of the trachea. And it is in the anterior, it is in the front, and behind it is the esophagus. And up here is the voice box, the larynx, up here. I showed you this once before. This is the inside the throat. You're actually seeing the cilia. And this is dust cells, which we found out were actually macrophages, and all kinds of other things being propelled along. There's your layer of mucus. And away they go. Just to let you know how much mucus there is and how much moisture there is, here is a slow motion picture of your vocal cords as you are sneezing. This is slowed down 200 times so you can see it. They don't talk about this in your book, but I wanted to point this out to you because you've probably read on liquor bottles and beer bottles, pregnant women should not drink. So here's a picture of a woman. Here's a normal nose, normal philtrum right there. But she drank while she was carrying her child. And the child was born pretty much without an upper lip, with very little of a philtrum right there. The eyes aren't correct, and the brain didn't form correctly. The child won't grow to normal stature in this particular instance because she must have really drunk quite a bit. So if you see someone drinking and they're pregnant, try to explain to them what they're doing to their baby. So you can tell the minute the baby's born just by looking at their mouth and their nose that the mother drank, and it's called fetal alcohol syndrome. Here's an autopsy picture of the concha, the meatuses, the nasal septum, the sinus. Here are some of the things you probably want to know the name of. Of course, you know the trachea, but the cricoid cartilage right here and the thyroid cartilage right here. This is called the laryngeal prominence. Only you and I just call it your Adam's apple, and it's much larger in men than it is women. Your hyoid bone is up here, right there. And if you are unable to breathe for some reason, they can actually put a tube right here and do what they call a tracheotomy. And you can breathe through your throat. I've seen people who have cancer of the mouth so bad that they actually have to breathe out of their trachea. And I've actually seen them go outside the hospital and smoke a cigarette through this hole right there. So it seems like you would kind of figure out that you really shouldn't be doing that. Now, if someone was choking, they had something stuck in their throat, and you couldn't do the Heimlich and push the air through and push the thing out of their lungs or out of this area, you can make a cut in between the thin and thick areas. You can and stick up like the head of a ink pen through there. Unscrew the ink pen, take the ink out, and just use the barrel to go in through there so that the person doesn't smother, so they can breathe through this area right here. And speaking of Heimlich, he had an idea, and I don't know why it hasn't caught on. But if you have emphysema or you have to walk around with one of those tanks of oxygen because your lungs don't work correctly, they blow it into your nose. Well, most of it's going to blow right back out of your nose. So you lose most of the oxygen, and some of it's going to go down the nasal passage and go down past the pharynx and past the larynx and down the trachea and into your lungs, but not very much of it. And he said, well, why don't you just put a small plastic cannula somewhere in this region and then you can hook up the oxygen to a little small portable tank of oxygen and just blow it in through here. So instead of it all going out your nose and out your mouth, it will be already in the trachea and then hopefully just go on down into the lungs. So I haven't seen that catch on, but heaven forbid if I get emphysema or something where I have trouble getting oxygen into my lungs, I will definitely suggest that rather than hauling one of those great big tanks around all the time. This is a picture taken through an electron microscope of the trachea, so you can really see the cilia right there. And then you can see the goblet cells that are secreting mucus, but of course this person's dead and they've cut this out, so you're not seeing it in action like you could in that other video where you saw the cilia moving and the mucus and the dust cells moving along with it. And here's where they've cut the lungs out of a person, so you can actually see down into the bronchial tubes and see the branchings in situ, actually inside the lungs. And this is a model that I bought a long time ago, but it's kind of neat because, again, they filled up the lungs with plastic and then they ate away the tissue so you can see the outlines. So we've been talking about the trachea and the bronchial tubes, and then the bronchioles are the little bitty branches, and then at the ends of the bronchioles we have the alveoli, and they're little grape cluster looking, looks like just somebody has a little bunch of grapes. So this is what the lung cells look like if you fill them in with plastic. Most people, when they see this picture, they go, "Oh, yuck." That's the picture of somebody who smoked. Oh, look at all of that. But that's not. That's actually a normal person because we breathe in so much dirt and not toxic substance, but dirty substance, soot, exhaust from cars, dust, that it actually fills up our alveoli. But this is a normal, fairly clean, healthy lung. This is the lung of someone who has lung cancer. And the number one cause of lung cancer is smoking. So don't do it. Look at this, blackened. You can still see the bronchial tubes branching off, but the tissue is blackened. If they were to put a scope down in and look in the inside of your lungs, this would be normal bronchial tube. And here's one with lung cancer growing. Abnormal cells, a lack of cilia. It's unmistakable. One thing I want to point out from this picture, this is slide number 20, is you can see the esophagus back here, and you can see the trachea right here, and you can see that if you swallow food, it could go either way. The other thing that you have to worry about is if you're going to put a feeding tube in a person because they can't eat, you don't want to accidentally push it in, come down, and go into the trachea and fill the person's lungs up with food, because obviously you will kill them. And if you're wanting to put a breathing tube in, they're always on the TV shows, they're going, "We've got to intubate them," meaning we've got to put a tube in so that they can breathe. We can force air into their lungs. You want to make sure that you don't accidentally get into the esophagus and blow air into the stomach instead of the lungs. I don't care if you guys learn this or not, but they take the throat and they divide it up into 3 areas. So the part that you can only pass air through, they call the nasopharynx. And then the part where you can pass air or food or drink, we call the oropharynx. And the pharynx is obviously used to swallow and to help us make speech. I don't know if you noticed that me pointing out the epiglottis when we were looking at those really cool pictures of people sneezing and coughing, but it is a big flap of tissue up above your vocal cords, and when you swallow, you close this down. The tongue pushes the epiglottis down, and so it will close off your airway. So food has to go down the esophagus behind the airway. So the epiglottis and your tongue keep you from sending food into the wrong tube. Now, I'm sure that your mother told you don't talk with your mouth full of food, because invariably a little of the food will trickle down, or you just won't think about it, and you'll just swallow a little bit of food, and you're busy talking, and you may be taking a breath of air in order to be able to talk, and you end up sucking the food down into your trachea instead of allowing it to go down into the esophagus where it's supposed to be. And so then you cough and you cough and you cough, trying to push the food out of the trachea. Here's the larynx from the front, the back, and from the side. And it kind of gives you an idea of why they call it the voice box. When we did the skeletal system, we learned about the hyoid bone and how it doesn't articulate with other bones. So it's the only bone that doesn't articulate with other bones. And what use is it? What is it doing there hanging at the top of your throat? It is a place where you can use ligaments to suspend the larynx. So it's literally your voice box is hanging from that hyoid bone. Because women have shorter vocal cords, it's hard for us to pull our cords or release our cords, make them as slack as possible to make our voice deep. But it's easy for us to tighten them and talk really, really high. So the air passes through the vocal cords, but you have to use your throat, your oral cavity, your tongue, your lips, and even your nose to get the sounds into words. So once again, in case you missed it, here is the epiglottis. It is upon the glottis. The glottis is this area right here leading up to the vocal cords, and this area right here leading up to the vocal cords. So that's your glottis, and there's your vocal cords. They have a name for that beating of the cilia that's carrying the mucus up towards the voice box so that you can swallow it down the esophagus. They call it the mucociliary escalator. Muco because mucus, cilia are propelling it, escalator because it's going upwards. Now, I mentioned before, and I want to mention again, if you smoke, you will paralyze the cilia. They will no longer be able to push mucus, and so all the mucus that you make will slide down the trachea and into the lungs. So you're going to have to cough it up, and that's why people have a smoker's cough, especially in the morning, because they've had all night long to accumulate mucus in their lungs. Anytime you put mucus in your lungs, you're not getting as much air as you should. And the other thing that mucus is protein, and bacteria love protein. So people who smoke keep a respiratory infection almost all the time, it seems like. So I was raised by a smoker, and his favorite saying was, well, I'd rather die young than give up smoking. So anytime you try to talk him out of it, he goes, I'd rather die young than give up smoking. And guess what? He died young of lung cancer. This is the picture I was showing at the very beginning. This is in the trachea. There's your cilia, there's your goblet cells. But it's an electron micrograph picture, And they're always black and white. So what they did is they colorized it so you could easily see the goblet cells and you could easily see the cilia. I try to point out when two words look alike but they mean something different. If you have a tracheotomy, they just make an incision temporarily to allow you to breathe through your trachea until they can get the thing out of your voice box or until they can remove the cancer up in your mouth. If they have to put a permanent tube in, they call it a tracheostomy. Ostomy, as opposed to otomy. And the other ostomy that you probably heard of is a colostomy bag. So sometimes people have colon cancer and they have to remove the colon, so they have no way to poop. And so they have a bag that's attached to them, and when they make poop, it goes into the bag instead of coming out the anus as it did before they had the colon cancer. So ostomy is permanent. Otomy is an incision that's temporary. I mentioned intubation earlier. You want to make sure that when you intubate and you want to get air into the lungs, that you go into the trachea and not the esophagus. You can do a manual ventilator where you use like bellows and you push the air in, and then they have mechanical ventilators. A long time ago, in a time most of you don't remember, there was a disease called polio. And one of the things that it could do was paralyze your respiratory system. So for the rest of your life, you had to be in an iron lung. So they could open this up, change the clothing, wash the person, but when they're doing it, the person can't breathe. So for the rest of their life, they got to lay there with this machine pushing, releasing, pushing, releasing. And what was tragic, it hit a lot of children. So they had whole wards where all of the people had polio and were unable to breathe for the rest of their lives. And of course, their lives weren't all that long. We have a vaccine for polio. We've wiped it almost off the face of the earth. So one of the things that worries me are the anti-vaxxers who say that people should not get vaccinations because there's some evil purpose behind the vaccination. But because we're having anti-vaxxers and because some unscrupulous man published a paper saying the vaccines caused autism, and then later had to admit he made it up, it was not true, he just needed a publication, but the damage was done and people believe it and they're terrified because they don't want to subject their children to vaccinations. So we have a whole new movement of anti-vaccine, and it bothers me so much. So by all means, get the vaccinations for anything that we've got vaccines for, so that we can wipe out things like polio. We've already wiped out smallpox. So let's get rid of some other diseases by encouraging, not forcing, but encouraging vaccinations. Once upon a time at another university where I was teaching, they gave me a little piece of money and told me I could buy whatever I wanted. So I immediately bought a set of lungs, and the students and I could hang it by the trachea. And then we had a mouthpiece where we could blow into it and we could inflate the lungs. And it was fascinating. The kids had the best time blowing in and watching the lungs inflate and then deflate. And what was so amazing is these look fairly solid, but when they're inflated, you realize how incredibly gossamer they are, how very fine they are. And you can look right through them because the walls are so thin with the flattened cells. if you remember from the last chapter, the base of the heart is actually the top of the heart, and the bottom of the heart is called the apex. But the lungs are the other way around. The apex of the lungs is the tip that projects above the clavicle. And you remember the clavicle is that bone that runs across from your shoulder towards your neck. There is a slit called a hilum, and this is how the lung gets the bronchial tubes in, the blood vessels in, the lymphatics, and the nerves. And when we do the next chapter and we're doing the urinary system, we're going to find that the kidneys have a hilum also. So this is just a word meaning a slit through which you can get things through, usually blood vessels and nerves. So the apex of the lung is the top and the base is the bottom. And the base actually sits on the diaphragm and rides up and down on the diaphragm. This is probably a good time to talk about things that could get sucked into your airway. The right bronchial tube is wider. So if you're going to breathe stuff and it's going to pass your voice box and go down your trachea, it's probably going to get lodged in your right bronchial tube as opposed to the left one, just because it's bigger. What do people get lodged in their throat? Two of the worst offenders are grapes. Little kids will swallow a grape, they'll get stuck in there, and they can't get it up and they can't get it down, and so they can't breathe and they die. So imagine feeding your child something really, really healthy like grapes and them choking on it and dying. So if it's a little child, they recommend you cut the grapes up into pieces so that it's not big enough to block the airway. And then the other one that's so easy to give a kid a hot dog. Kids love hot dogs. They can pick them up in their hand and bite them, and they'll get a great big old chunk, and they'll get stuck in their airway. So it's important, if you're going to give your kid a hot dog, cut it up in pieces. Make sure at least you cut it in half so that it's not round, because it's just perfect to plug up the airway. So if you have little children, look at the food you're giving them and think, could that get stuck in their airway? And like I said, grapes and hot dogs are two of the big ones that you absolutely want to cut up and not give your kid whole. Two other interesting things you need to know about the bronchial tubes. They have mucosa associated lymphoid tissue, or malt tissue. So we're going to see that again and again. One of the other places in the intestines, you have this mucosa associated lymphoid tissue that we talked about when we did the immune system. So you're going to find that, which is good, because if something manages to make it past the nose, the concha, down through the pharynx, down through the voice box, and finally make it into the bronchial tubes past the trachea, you may very well have little tiny pieces of viruses, bacteria, worms, and things like that you need to kill. So it's positioned to intercept inhaled pathogens. And the bronchial tubes are elastic. They have a lot of elastic connective tissue in them so that they're able to give, and they're able to constrict, and they're able to dilate. So this elasticity, it says, contributes to the recoil that expels the air from the lungs. So one of the odd things that people don't really think about until they take a class like this is your lungs do not expand and contract by themselves. They are not an elastic thing. They are sitting on the diaphragm, which is a muscle and a membrane that allows them to move up and down on it, and they have the bronchial tubes inside, which are elastic and can recoil and help. but the lungs themselves do not inflate and deflate, just like that picture that I showed you where we had some lungs and we were blowing them up. They don't blow up by themselves. You've got to have air forced into them, or it's pulled in as they ride down on the diaphragm. One thing that's kind of important is the bronchial tubes branch out and they become so tiny we call them bronchioles. They do not have mucus glands or goblet cells because you do not want fluid running into the alveolar sacs. Because if you do that, then you can't get air into the alveolar sacs and you can't get oxygen. So not only do you not have mucus glands or goblet cells that far down towards the alveoli, but you still have these cilia that are moving what mucus there is up so that it doesn't come down into the alveoli. So those little grape-like sacs, you've got roughly 300 million of those little sacs, 150 million in each side, and they're made out of squamous epithelial cells, and then they have those alveolar macrophages, or which we call dust cells, rolling around in them, eating all sorts of stuff that makes it all the way down to the alveolar sacs. Because they're squamous epithelial cells, because they're flat, they allow rapid gas transfusion between the air and the blood. So on the other side of the alveoli, touching the alveoli, are capillaries. So you suck air into the alveolar sac, into the alveoli, and because it's squamous epithelial, and because the capillaries are squamous epithelial, it is able for the gases just to pass out of the alveoli and into the bloodstream of the capillary, and the capillary is releasing carbon dioxide. So this is where diffusion is important. If you've got more oxygen inside the lungs than you have in the capillaries on the other side of the alveoli, then the oxygen is going to go out of the lungs and into the capillaries, which is exactly what's happening. If you've got more carbon dioxide inside the capillaries, it's going to diffuse out of the capillaries across the alveoli and then be exhaled to exit the body. So it goes from a high concentration to low concentration. You do have about 5% of your lungs that is not alveolar tissue. It is cuboidal cells, and if you remember, cuboidal cells are usually secreting something. So in this case, they are secreting surfactant. So two of the things that they can do, they can damage the they can repair the damage of the squamous cells, but then they can coat the entire surface of the lungs with this surfactant. So if you just had moisture, if you just had wetness in the lungs, every time you exhaled and your lungs shrank up, they would collapse because they'd stick together because of the water. You don't want this to happen. So the surfactant breaks the surface tension of the water. It breaks it up. It's almost like a detergent. And so when you exhale, the surfactant coats the lungs and keeps them from collapsing. So then you can inhale and they'll fill back up again. Now, one of the things that is dangerous for a small child that's born prematurely is one of the last things to make or develop are your lungs and the surfactants. So if a baby was born before 7 months, it usually died because it didn't have well enough developed lungs and it didn't have surfactants, so they couldn't keep the lungs inflated. There was a movie that came out in 1989 called The Abyss, and this is an actual thing. There is a fluid that holds oxygen, and you can actually breathe this fluid. So now we are able to save babies much, much younger than 7 months because we can use this fluid in their lungs to keep their lungs inflated and to keep oxygen in them. So I'm going to show you just a little excerpt from the movie, but I highly recommend you watch the movie. It's pretty cool.
Anyway, you breathe liquid so you can't get compressed. The pressure doesn't get you.
You mean you got liquid in your lungs?
Oxygenated fluorocarbon emulsion.
Bullshit.
Check this out. Can I borrow your rat?
What are you doing?
Hey, no.
You're gonna kill her!
It's okay, I've done this myself.
Oh man, look, what are you just drowning her?
He's gotta be fine. I breathed this myself. Gotta be fine.
No man, she's gonna drown. Look, she's freaking out.
Just going through a normal adjustment period.
Normal? Does this look normal to you? She's gonna drown.
He's taking the fluid into his lungs. He's taking the fluid into his lungs. There he goes. So there's a bit of anxiety here. Now he's starting to relax. He's breathing fine. See his chest moving? Getting plenty of oxygen.
Damn rat's breathing that shit. That is no bullshit, hands down. The goddamnest thing I...
Here's your rat. See, he's fine. It's a she.
Going over the wall.
I apologize for the 4-letter words in there, but hopefully you thought that was pretty cool, like I did. So that's a real rat breathing this fluid that they've got, that they put in premature babies' lungs so that their lungs can finish developing. Something to know, but not necessarily memorize, 100 million of those macrophages, the dust cells, die each day because they ride up the mucociliary escalator and they're swallowed and digested with all of the stuff that they've phagocytized, that they've eaten. So just think, every single day, 100 million of your white blood cells die because it rides out of your lungs and up and then down into your stomach to hit the acid. I'm going to stop here, and when we have the next half of this chapter, I'm going to start talking more about what goes on at the alveolar sac itself. So here is a picture to stay in your mind. Here are the grape-like clusters, except for they're hollow for the air to go in. And on the outside, you can see all the capillaries. Some of them bringing in blood that doesn't have oxygen, picking up the oxygen, and then carrying it back out